Welcome, everyone. You are now watching the presentation for Geospatial Audio, Localized Experiences Using AR and GPS. So starting off with our team, our PIs, Daisy and David are the directors of a lab department at UBC called CEDAR, which stands for Community Engaged Documentation and Research. Their goal is to establish a collaborative new media space at UBC Vancouver designed to facilitate community-led innovation of relational technologies. For the series of projects with EML, the communities that they're specifically targeting at the moment are the First Nations and the Indigenous communities. As for the rest of the team, you have me, myself, the team lead, Olivia. In development, we have Nima Wax, Michelle Hume, and Dante Cerrone. In design, we have Vita Chan. In advising, we have Catherine Winters, Erin King, Hannah McGaugan, and Vanessa Campbell. Before we begin, seeing that the subject matter of the project, it is only appropriate that we acknowledge that we are gathered here where the project Geospatial Audio is created on the traditional, ancestral, and unceded territories of the Coast Salish peoples, Squamish, Tsleil-Waututh, and Musqueam nations. Moving on to the subject matter, we've received a total of 3 proposals from our PIs. With those, we found similarities in development needs of each project. Therefore, the team and the PIs have agreed to create a proof of concept using one of the projects from the 3 proposals called Musqueam Street Signs at UBC. If you have visited the UBC Vancouver campus, you will probably notice that the street signs on the main roads of the campus are bilingual. Our task is to take these street signs and create a spatial audio experience for our users to better understand how these are named on a place-based basis in Hunkaminam. The end product that we're envisioning will be a React web application specifically for mobile devices to suit the traveling nature of this project. Our database will also be stored in Drupal because it provides us the flexibility of how the interface could look from project to project, and the development team won't have to hard code the data.
Since we are creating a database in addition to an end product, there are 2 different types of users to consider. So authenticated users will be using Drupal to upload, edit, and delete content. For example, in our proof of concept with the Musqueam street signs at UBC, an authenticated user would be responsible for inputting where the street signs are located and their corresponding audio recordings. And touring users will be using the end product. So again, in the case of the Musqueam street signs, the touring user would be using the final mobile application to navigate across campus in order to find the street signs and therefore listen to the recordings.
Currently, there are 2 methods of accessing geospatial audio. The first method is inputting the website URL into the browser such as Google, and the second method is to scan a QR code. At the moment, QR code is simply used to link the user to the Drupal website. However, future implementations aim to generate custom URLs that link QR codes to the app at specific locations. So if I were to scan a QR code at Agriculture Road, it will show the image and the general location and direction I am facing on the small interface below. Any important information from the Drupal website can also be shown. Another key feature in progress is having the user enter the app through a GPS location trigger. When a user who has an app approaches the key location and faces the direction of the sign, the app will automatically trigger and run the geospatial audio. Thus, the user will not necessarily need to check their phone to see if they are at the right location.
What the PIs would provide us with is a photograph of the street sign, which we will then convert into a file type called an NFT, which is not a non-fungible token. It's a different type of file for image recognition specifically that allows a user to be able to look at that street sign from multiple different angles and have their phone recognize it. So what the user will then do is bring the camera up on their phone, point it at the street sign in the app, that will recognize that it's the right place, and it will trigger audio for the experience.
So far, we've talked about ARJS and using geopositional information, besides work that's being done in the Drupal backend and the way people will access the application. All of this comes together in the context of a 3JS application. We've used 3JS in our project in the past. For this one, we're using a framework called the React 3 Fiber. This framework allows us to take advantage of React state management and manipulation as well as JSX. Essentially, React makes 3JS much easier to develop with, and even better, people are constantly publishing their own 3JS React Fiber components. The positional audio component that we're using, the leaflet map that we're planning on implementing, and also ARJS has its own React Fiber component. There's an example of the positional audio component linked in the slide. Just looking up 3JS positional audio will give you a cute little boombox where you turn the boombox around and you can actually see how it affects the audio that reaches your ears. For this upcoming term, I see us incorporating the data that has already been added to our Drupal backend and our AR sync with positional audio before focusing on user testing and getting the app into people's hands. Thank you, everyone.